This is a summary of modeling multiplication problems. So again, a model should represent the original problem and your method and make it clear how your method solves the original problem. So these first examples will deal with the distributive property. So for example, if I had 12 times 7, but then I split my 12 into a 10 plus a 2, and then I were to distribute my 7 to both of them, then I would end up with 10 times 7 plus 2 times 7. This is the distributive property, but a model sort of shows why and how this works. Now again, I'm using the strip diagrams where, each 7 is really meant to represent like 7 cubes, so I have a block of 7. And so up here, like I said, it should represent the original problem and our method. So we should show that the 12 groups of 7 is the same thing as 10 groups of 7 and 2 more groups of 7, right? So we have 12 groups of 7 over here, and you can clearly see this is 12 groups of 7 if you count, and I want to show that that's equal to 10 groups of 7 and 2 groups of 7, and this picture, if I were just to split it right here, would clearly show that, right? Because I can look at the picture and I can see 12 sevens. I can also see 10 sevens, and I can also see 2 sevens. So you have 10 sevens here and 2 sevens here. And then, 10 times 7 is 70, plus 2 times 7 is 14. And so you'd add that together and we could solve this problem as 84, right? This is 10 times 7, so that would be 70. And this was 2 times 7, so that would be 14. And you add those together and you get your overall value of 84. So again, the model shows the original problem and our method and why those two values should be the same thing. So here's another one, same basic concept, but on a number line. So up here I have 12 groups of 7, and the question is, what is 12 times 7? So that's what we're looking for right there. However, I'm saying that we can split this into 10 groups of 7, so we can go up 7 10 times, which is 7 times 10, or 70. And then if we were to go up another 2 groups of 7, which is 14 more, that should bring us to the answer we are looking for, which is 84. So again, model should show the original problem, 12 groups of 7, and our method, 10 groups of 7 plus 2 more groups of 7. All right, now I'm going to flip it. So instead of 12 times 7, I could do 7 times 12, or 7 groups of 12. And now I can split this into 12 as 10 plus 2, use the distributive property, and we get 7 times 10 plus 7 times 2. And so this shows 7 groups of 12. We need to show that that's the same thing as 7 groups of 10 and 7 groups of 2, right? And that's what this says. So if I look at this model, here there are 7 things going this way, and there are 12 dots going this way. And so if I highlight it, I have 1, 2, 3, 4, 5, 6, 7 groups of 12. But if I were to change this color, we can see hopefully that over here is 7 groups of 2, and up here we hopefully have 7 groups of 10. So 7 groups of 12 can then be seen as 7 groups of 10 and 7 groups of 2. And this model hopefully shows both of those things and why they would be equal. All right, models with the associative property. So if I wanted to do 12 times 25, I could also say, hey, I know that 12 is 3 times 4. And I could then multiply these first, and I could say, well, I know that 4 times 25 is 100, and so I could do then 3 times 100, which is 300. So again, the model should show the original problem, so clearly I can see 12 groups of 25. You could think of these as 12 quarters, 25 cents, or just 12 25s. Each circle represents 25, and I've got 12 of them. But I need to show that my 12 groups of 25 is the same thing as 3 groups of 100. Right, so if we get rid of all of this extra stuff up here, we have 12 groups of 25, and I want to show that that's the same thing as 3 groups of 100. So I can do that by simply, let's see, if I were to circle 4 of these, now I have 4 25s, which would make this 100, 100, and 100. So I can clearly see that my 12 25s is equivalent to 3 100s, and these 100s are also grouped as 4 groups of 25. Each 100 is made of 4 times 25. So again, this model shows the original problem, and it shows how it's equal to 3 groups of 100, and even those 100s are grouped as 4 groups of 25. Now, same problem, 12 times 25, but I want to choose to group it differently. So yes, there are 12 groups of 25 here, but I'm going to turn my 12 into 6 times 2. And then I'm going to make that 6 times 2 times 25, which is the same thing as 6 times 50. And so I should have 6 50s, and that will happen if I group these by 2. Now when I look at this, hopefully I have 6 50s, 50, 50, 50, 50, 50, 50, 50, 50, 50. And each 50 is 2 25s. All right, that is it for our multiplication modeling summary.